Hi guys, how you going? Today we're just going to be looking at an example where we're shooting an arrow below the horizontal. Now this is very unusual and I don't actually ever recall seeing a question like this in an exam, but we'll think about, doing it because it's not hard on what we've already done. So if you're shooting an arrow below the horizontal, it's going downwards initially and then it will be doing a parabolic path. Here imagine having a line across here. That angle there is 10 degrees. So we're launching from a cliff which is 30 metres high, and we know what this initial speed is. So again we have to use our triangle here. So if you were going to draw this, you're going to say your VH is the one going down this way. Alright, so this is our V horizontal and our V vertical. So and our initial vertical, our vertical component velocity is going to be negative, isn't it? It's going to be going downwards. So let's do it. So V is going to be equal to simply 50 sine of 10, and our V horizontal is going to be equal to 50 cosine 10. So go to our calculator and do that. So 50 sine 10. That 50 cosine 10 equals that. So we can write those two answers down in our particular thing. So that works out to be 8.68 meters per second, and don't forget the negative because it's going downwards. The other one is in fact going to be 49.24 meters per second. That's positive. Right, so again, this is the next part is really the only part that changes, right, for this thing over here. So from our starting position to where we're finishing, we're in fact going down minus 30 metres. Our initial velocity is in fact minus 8.68 times by t, take 4.9 t squared. So normally that would be positive, won't it? So therefore, minus 4.9 t squared, take 8.68t. Now when you bring the 30 across, it's going to become plus 30 equals 0. Now we have to solve that for when t. Okay, so we go to our calculator, we go to our polysim. Alright, so come down to the polysim, enter. Alright, so number 1, so that's a quadratic. Now, A is still the same. This is going to be negative 8.68, which is unusual, but normally it's positive. And then that will be 30, because remember the negative 30 come across to become positive 30. And all we have to do is press solve, and we get 1.74. Okay, so t is equal to 1.74 seconds, based on that information. Now, everything else is again going to be the same sort of information. To find the range, SH is equal to our VH. Now, VH is 49.24 times by our time of flight, which is 1.74. And so you can work that out. Remember, we have to quit out of here. 6. By the way, if you don't have polysim on your calculator, ask me and I'll give you a copy of it. It's not hard to install. So 49.24 times 1.74, and that will give us an answer of 85.7 or 68. 85.68 metres. 85.68 metres. Okay, to work out our vertical velocity, or our velocity when it hits the ground, remembering this is starting off with a negative velocity, so our VV is equal to our VV0 plus AVT, so that's minus 8.68. Take 9.8 times by the time of flight 1.74. So it's going to get basically bigger, isn't it? It's going to have a bigger V, so it's minus 8.68 take 9.8 times 1.74. So that gives me velocity minus 25.73. So minus 25.73 meters per second. So that's going downwards, and so therefore our velocity is equal to simply the same sort of thing again, 49.24 squared horizontal plus our vertical 25.73 squared. Our theta over here is going to be inverse tan of our vertical component, 25.73 all over 49.24. So you can go to the calculator to work those two things out. Remember to do this in one step. So 49.24, we square it, plus 25 point, what was that again, 25.73, we square that, and then enter, so 55.56, so 55.56 meters per second. The angle, right, is inverse tan of 25.73 divided by 49.24 gives an angle of 27.6. So equal to 27.6 degrees. So therefore velocity of 55.56 meters per second at 27.6 degrees below the horizontal. Alright, so you get the idea again. Now, in terms of the maximum height, that doesn't make sense to do a maximum height because it's going downwards, isn't it? So it's only going to get lower and lower. So that part of the question we wouldn't do. Interesting, the only difference between what we've done, again, with all of these things over here, is we've just put this into our time of flight. So really part B, so step B, is really the only bit that will vary a lot of the time. Okay, so keep in mind, if you have it going downwards, you need to use a negative velocity. If it's going upwards, you need to use a positive velocity. Alright, so good luck with the rest of the questions in the chapter for that.